Hey everyone, this video is on linear algebra LU decomposition. And the idea of LU decomposition is to express some matrix A and express it as L, which is a lower triangle matrix, and U, which is an upper triangle matrix. All that means is that in the matrix, in the lower triangle matrix, the part that is not in this lower triangle is all zeros, and the part that's not in this upper triangle is also all zeros, and the rest are filled with numbers inside the triangle. And the reason why it's so much better to express the matrix A as two components, L and U, it's because it makes solving matrices like A in an equation like AX equals B, it makes the calculations a lot faster when you have the same A, but you have a different B each time. Let's say we have this matrix A. Our goal is to turn it into an upper triangle, which means these three entries over here must be equal to 0. So how do we do that? Well, we know our first row is going to stay unchanged because we don't need any 0 entries in there. Now, for the second row, we want this entry to be 0. So this is the second row and the first column. And this L over here is the number we have to multiply the first row by so that our second row and first column entry turns into 0. So we multiply the first row by 3, right? And then if we do that, 1 times 3 is 3, and 3 minus 3 is 0. So now we have a 0 in there. So L21 is 3. Then we do the rest of the row. 2 times 3 is 6, and 8 minus 6 would be 2. And then 4 times 2 is 8. 4 times 3 is 8. And then 14 minus 8 would be 6. Now we do the same thing for this value. This would be the third row and the first column. So the number we multiply the first row by to get L31 as 0 would be, we would multiply this by 2. We'd multiply this by 2. 1 times 2 is 2, and 2 minus 2 is 0. Then 2 times 2 is 4, and 6 minus 4 is 2. And lastly, 4 times 2 is 8, and 13 minus 8 would be 5. The last entry we need to make 0 is this one right over here. So now let's use the second row to do that. So we want to eliminate this one, which is 3, 2, right? The third row and the second column. So let's use the second row to do so. So this is already 2, so all we have to do is multiply it by 1 and subtract. So the first row stays the same. The second row stays the same. And then the third row, 2 minus 2 is 0. And then 5 minus 2 is 3. Now we have our upper triangle. But where's our lower triangle? Well, that was the point of storing all of these numbers right over here. How to construct your lower triangle now is that you put 1s along the diagonals and 0s on the upper right portion right over here. And what makes it a lower triangle is now we plug in these 3 values based on these numbers right here. So in row 2, column 1, we plug in 3. And then in row 3, column 1, we'd plug in 2. And then in row 3, column 2, we'd plug in 1. So then our U would be our matrix that we found, the upper triangular matrix. And what LU decomposition says is that this original matrix that we had is equivalent to if we multiplied this lower triangular matrix by this upper triangular matrix. Let's multiply this out to see if it's actually equivalent to this. Well, for this first row, we're saying that we need 1 of the first row, 0 of the second row, and 0 of the third row. So our first row of A stays the same. That's equal so far. Then we need 3 of the first row, 1 of the second row, and 0 of the third row. So then that would be 3, because we have 1 times 3 plus 0. And then 2 times 3 is 6, 6 plus 2 is 8. Then 4 times 3 is 12, and 12 plus 2 is 14. So our second row is also the same. Then for our last row, we need 2 times the first row, 1 of the second row, and 1 of the third row. So 2 times 1 is 2, plus 0, that's just 2. Then 2 times 2 is 4, 4 plus 2 is 6. 6 plus 0 is 6. And then for our last one, we have 2 times 4 is 8. And then 8 plus 2 times 1, that's 10. And then 10 times 3 plus 10 plus 3 times 1, that would be 13. So as you can see, these matrices are equivalent and LU decomposition works. See you in the next video.